Okay, I have problem number 1.73, and it says, while following a treasure map, you start at an old oak tree. You first walk 825 meters directly south, then turn and walk 1.2 kilometers at 30 degrees west of north. I'm going to start with that and draw it. So we go 825 meters south. So this is where you go. And then you go 1.25 kilometers at 30 degrees west of north. So if you're going west of north, you're going this direction. Kind of go like this. This is 1.25 kilometers. But since this one was in meters, I'm going to change this one to meters, and I know a kilometer is 1,000 meters. It's going to be 1250 meters. That's what we're going to use. Then you turn and walk 1 kilometer at 32 degrees north of east, where you find the treasure. So to do vectors, you have to do the other little graph and go 32 degrees this direction. And you're going 1 kilometer, but again, I'm changing that to 1,000 meters, just so all of our units are the same. And then the degrees were 30 degrees here, and 32 degrees here. Okay, and you're trying to find in what direction and how far you will walk to return to the old oak tree, which was right here. So this is the distance you're trying to find. This isn't drawn to scale. It's roughly to scale, but not completely. So we don't know exactly if it's in this direction or not, but it's a guess. So first, these are all vectors, and so we're going to use components of vectors to figure out where we are, because in order to find out how far this is, we have to find out where exactly we are. So I'm going to put all these lines into coordinates. So for the first one, you didn't go east or west any, so it's 0, and you went south 825 degrees, and south is negative and west is negative. Negative 825. For the second one, you don't know the exact length, and this is the triangle you're roughly trying to find. So you don't know the length of up here or over here. So you're going to have to use sine and cosine, because you know the angle measure and you know the adjacent, and no, you know the hypotenuse, and you're trying to find the adjacent and the opposite. So for this line, the y, we're gonna do, so it's sine of the angle measure is the opposite over hypotenuse, but in this case it's the magnitude, and the hypotenuse is always the magnitude, so that's going to be that. And for all of them, I'm not going to do this every time, but you have to solve for what you're trying to find. So it's going to be the hypotenuse times the sine of the angle measure. It's going to be what you're looking for. Okay, so for the y line, we're going to do 1250, because that's our hypotenuse, of cosine, because we know we're trying to find the adjacent, of 30. And for our x line, it's going to be sine, because we're trying to find the opposite. I'm just going to get this out of the way a little bit. And then for this line, we're trying to find roughly this triangle. with this angle measure and the hypotenuse being that. So we know the hypotenuse is that. Since we're trying to find, for the x, we're trying to find the adjacent. It's going to be cosine 32. And for the sine, we're trying to find the opposite. So it's going to be that. Okay, and then to find out where we are, we're going to add up all the vectors. It's going to be x, y. So the x is going to be all the x values added up. So 0 plus 1250 sine of 30 plus 1000 cosine of 32. And then for the y's, it's going to be negative 825 plus 1250 and then I already added all of those up, and the x is 223.048 meters, and this is rounded. In my calculator, when I was calculating it, I didn't round it, but just for sake of writing it, I did. So 787.451. So that's where we are. So this is where this point is. So these are both positive, so we know we're in this realm. So this drawing was a little accurate. So now we have this triangle, and I'm going to blow that up over here. And we know that x and y, and we're trying to find this. I'm going to call that A. And we're trying to find this angle measure. So first we're going to use Pythagorean theorem to find A. So of x and y. And I calculated that out already, and A is 818.4 meters. So for x and y, you're just going to plug these values in. So there. So this is how far we're traveling to get back to the oak tree. Now, we're trying to find the angle measure to know which direction we're heading and at what degree. So for that, we're going to use tangent, because we know the opposite and the adjacent and the angle measure. And we're trying to find the angle measure. So tangent of the angle measure is opposite, so x over y. And again, you're just going to plug these values into there. And I also already calculated that one out, and you're going to use arctangent, so when you put it in your calculator, you're going to use tangent -1. But I found out that the angle measure is 15.8 degrees, and in this picture, we are heading southwest, so that is the direction. And this picture is drawn roughly to scale to see what direction and how far you're traveling to get back to the oak tree.